Greetings to you. Welcome to Physics with Ben. In today's video, I would like us to look at the topic gravitational field and looking at Newton's law of universal gravitation. By the way, what is a field? A field is defined as a region or a space around which the influence of some physical agents such as magnetic force, electric force, gravitational force can be felt on an object placed in the field. I have a magnet here to demonstrate magnetic field. I just watch something. What do you see? What do you see? What do you observe? What do you observe? If I take it this way, you will see that. Watch. Watch. The moment the key gets to this region, it is attracted to the magnet. It means that this region is where the magnetic field is. Anything outside this field cannot experience magnetic force of attraction. And so the Earth is the chief field or the chief area of gravitational field. That is why on Earth here they will tell you whatever goes up has come down. Whatever goes up has come down. Go to space and you won't say that again. You drop this guy, you see this guy floating. Ask the astronauts and they'll tell you what they're experiencing in space. So we want to state Newton's law of universal gravitation. Newton's law of universal gravitation is a very important law in discussing gravitational field and all planetary motion. The law states that every particle of matter in the universe is attracted with a force that is directly proportional to the product of their masses, m1, m2. Product of their masses, m1, m2, and inversely proportional to the square of the distance between them. Mathematically, you have your F is equals to is directly proportional to m1, m2, and your F is inversely proportional to r squared. What this law is saying is that let me have something like this. The first law is talking about something like this. You have product of small masses and product of what? Bigger masses. Yes, this is m1, m2. This is m1, m2. That if these masses, between these two masses, the force of gravity will be stronger on these masses than it will be on these masses. The bigger the masses, the greater the force of gravity. The second law, the second part of the law. What the second part of the law is saying is this: that if we have mass m1 and then another mass m2, and this is the center of the masses, and this is the r, all in kilogram. This is another mass, and this is another mass. This is ma, mb, all in kilogram, and this is the center of the masses. What this law is saying is this. What the second part of the law is saying is this: that the increase in the square of the distance will cause the decrease in the square of the distance will cause the gravitational force of attraction to be great on the object. So in these two diagrams, the force of gravity will be greater on this object, and the force of gravity will be less on this object because the distance between the center of the masses here is increased and here it is decrease. So combining these two variations, you have what I call have F is directly proportional to m1, m2 all over r squared. Removing this sign of proportionality, you will introduce a constant called G, gravitational constant. Your F is equals to big G m1, m2 all over r squared. This is the equation that explains Newton's law of universal gravitation. You can call this equation number 1. And so I'm done explaining the meaning of the equation. We will quickly look at the mathematical relationship that exists between big G and small g. Mathematical relationship that exists between mathematical relationship between big G and small g. Now, let's write. Why we ask you to say, show that, there will be a question like this, show that G is equal to G, capital G, M-E all over R-E squared. Show that this is equal to this. How do you go about it? Very, very simple. Now let's write solution. Now, recall that your F is equal to G M1 M2 all over R squared. So we can baptize this equation by saying this is ME and this is just ordinary M and this is what? Capital RE squared. You can call this equation star. Recall also that your F is equal to what? Mass times G. Equation star star. Now quickly, somebody will ask, why are we equating, why are we using mg here? Why are we using this? There's what I call the physics of cut and join. The physics of cut and join is a physics where you make use of simple basic equations to produce advanced and complex equations that are used in solving very, very difficult equations in physics. Now, there is in such mathematical manipulation, you have to equate an equation with another equation. There are two conditions for doing that. Number one, the two equations or the three equations you are equating with each other must have the same SI units. Number two, the two equations must be used in the same condition. Now, it is physically and mathematically wrong for me to equate this equation in this topic with F is equal to MA. You know that this also false, right? Yes. Why? Because F is equal to MA is used under linear motion. And this guy is used for motion under gravity. And so, these two equations have met the same condition. Condition number one, they must have the same SI unit. Number two, they must be used under the same condition. Both of them are used for motion under gravity. So we can say that equate equation star with equation star star. So this implies that your G M-E M all over R-E squared is equal to what? G M times small g. If you cross multiply, you have something like this. You have G M-E M, this is all over 1, times 1 is equal to what? M is equal to what? Is equal to R-E squared times M times G. Of course, this M, you cancel this M. And what do you have? You have your G M-E is equal to what? G R-E squared. You can flip this equation this way. This is a look at it here. So you are free to say that your G R-E squared is equal to G M-E. So we divide both sides by R-E squared. Divide both sides by R-E squared by R-E squared. This is only this. And sorry. R-E squared. This will cancel this. Therefore, G is equal to what? Capital G M-E over R-E squared. This is the mathematical relationship that exists between gravitational constant, big G, and acceleration due to gravity. Acceleration due to gravity. This is the equation. What is the meaning of this equation? The equation means that if an object is very far away from the center of the Earth, an object is going up high in space, the value of G on that object will decrease, will be small. And while this G, capital G, is constant everywhere, if the bigger the mass of the object, the greater the gravitational force of attraction will be on that object. If Big Show and I will stand on a weighing machine, Big Show will weigh far, far greater than me because he has what? Much mass, and what? And me, I have what? Less mass. So that's the meaning of this equation. Increase in mass, increase in the value of G. Decrease in radius, the distance between the two objects, decrease in the value of G. Pictorially, this is the meaning of this equation. If I will draw this as the Earth, and from here to here as the radius of the Earth, and from here to here as the distance between, and this is the mass of the Earth. So what this law is saying is that this is mass of the satellite. If you take an object very far away from the center of the Earth, the value of G will decrease. Very close, the value of G will increase. If the object has a bigger mass, the value of G will increase. If the object has a smaller mass, the value of G will decrease. There was a day my students and I ran an experiment in this school. I was standing where I'm standing right now, and we ran an experiment, and the value of our G here in this place was 9.8 meters per second squared. I told them to go upstairs and run the experiment to the last floor. And they did, and they came back, and their value was what? G equals what? 9.23 meters per second squared. Per second squared. In the same school, we performed an experiment and got this and got this. It means that the higher you go up, the lesser the value of G. It is in line to this that we hear people talking about zero gravity. There's actually nothing like zero gravity. We only have negligible magnitude of gravity in space. It is in line to this that when you go in space, objects float in space. The law that says whatever goes up must come down is not applicable in space. So this is the meaning of this equation. So we'll quickly look at derivation of escape velocity. WAEC examiners may ask you to show that VE is equal to 2GR, where VE is the escape velocity of the satellites. Now, let's consider this diagram. As the Earth, and this is the center of the Earth with RE, and this is the mass of the Earth. And if we draw another line here, so this is the mass of a satellite MS, and from here to this point is your distance R. Do you see that? Yes. Now, there's a force of gravity acting here. Now recall that we want to actively show that this equation is solution. In attempting to this question, it is very, very imperative you draw, because it will throw more light to what you are doing. Solution. Recall that F is equal to what? G ME. Recall that your F is equal to G M1 M2 all over R squared. Now, the reason why I'm writing and cleaning, I want to throw more light on this. You are free to change this variable as this. Your M1 becomes your ME, and then just ordinary N. And then this one just write what? Your RE. Yes, you can write your RE squared. So call this equation number 1. Now, for this satellite to be taken away from the center of the Earth to this point with an escape velocity so that it won't come back to the Earth again, work needs to be done under gravity. And that work done is given as W is equal to force times this distance R. The distance between this satellite and the mass of the Earth, this is space. This is space. Yes, that is space. So the distance between this satellite and mass of the Earth is R. So the work done is force times distance. Call this equation number 2. Now we are going to make F the subject of the formula in equation number 2. So this implies that your F is equal to what? W all over R. Call it equation number 3. Equation number 3 and equation number 1 has met the condition of equating them with each other. They have the same SI units and they are used in the same condition. The physics of hot and general recall. So this implies that we equate this factor with this factor. So this implies that GME n all over RE squared is equal to what? W over R. Call this equation number 4. Now if we cross multiply, we have we have W RE squared is equal to what? G M E M R. Yes, we can equally call this RE. RE. That is it. So divide both sides by RE squared. I mean this RE squared. RE squared. This will go, this will go. So R will cancel R here, 1, and we left it what? 1 RE down here. So if we do that, you are having your W, please look at this very well. We are having our W equals to G M E N divide by what? RE squared. Call this equation number 5. Equation number 5. So, equation number 5 is the work done needed to be done against gravity to take this satellite away from the center of the Earth to in space where it will experience the force of gravity but keep floating in space. That is it. Now, right, let this work done, let W because of what? Kinetic energy of this satellite have what? mve squared. Now this VE is what we call the escape velocity. We call this equation number 6. So equation number 6 and equation number 5 has met the condition for equating each other. Work both in joules, and both of them are work done under gravity. So it implies that equation 5 is equal to what? Equation number 6. So this implies that G M E M over RE squared is equal to what? Half. Is equal to what? Is equal to half mve squared. Equal to half mv squared. You can call this equation number 7. Equation number 7. So we can clean this side to continue with the solution. So if we do that, we have G M E M all over RE squared is equals to mve squared mve squared all over what? All over 2. So if we cross multiply, we have mve squared RE squared is equals to G M E is equals to 2G M E N. This N we cancel out this n. Yeah, this n will cancel out this n, and you're left with VE squared RE squared is equal to what? 2G NE. Divide both sides by RE squared by RE squared. This goes this way. What do you have? Your VE squared is equal to what? 2G NE over RE squared. If you do that correctly, what do you have? If you do that, we want to get rid of this guy. We want to get rid of that G. So recall this equation number 8. Recall that your G is equal to capital G NE over RE squared. So we're going to make G the summit of the formula. If we do that, you're going to have something like this. We have G NE is equal to what? G RE squared. So divide both sides by NE. Divide both sides by what? NE. This is good. So your G is equal to what? G small g RE squared divided by what? NE. So we are going to put this guy here. Put this guy here. So if we do that, it implies that VE squared is equal to what? VE squared is equal to 2. Is equal to 2 times G RE squared divided by NE times this NE here. Then all divided by RE squared. This will cancel this, and your VE squared is equal to what? Your VE squared is equal to what? 2G RE squared divided by what? Something is missing somewhere. What is that? Yeah. This is it. Over RE. Yes. Not square here. Not square here. Yeah. This was dealt with. This was dealt with. Yeah. Yeah, this is it. This is it. GME over I square square. Yeah, it was dealt with. It was dealt with. That is it. That is it. The mistake was here. This was where the mistake was. So this is it. This is it. Thank you for. That is it. That is it. That is it. So this is what we have. So you have this. If I can clean this side, we have V squared. We have VE squared is equal to 2G RE squared divided by RE. This will cancel this. We are left with 2G RE. So we have VE squared. So therefore your VE is equal to the root of 2G RE. This can also be written as VE is equal to what? The root of what? 2GR. Proof. We call this the escape velocity. These satellites need to move from the center to this place with this velocity so that it will escape the Earth's gravitational force influence and never to come back to Earth again. Look at it and screenshots. Yeah. To this, we have come to the end of this particular video. I will make a very short video on how to derive Kepler's third law of planetary motion. Thanks for your time and God bless you.